All right. Today we're going to go ahead and get started with chapter 3. Tests will be handed back to you next class on Monday. So we're going to go ahead and jump into our next chapter. In our next chapter, we're going to continue to work with trigonometry, but we're going to work with it in some different ways than what we were doing in chapter 2. So it's still trig, but it's from a little bit different perspective. Okay? All right, so let's go ahead and get started. So if I give you a problem like this, where you can see the triangle, and you can see that on the triangle there are some different parts of it that have been labeled. And then your directions say to solve the triangle. What do you think that the directions are asking you to do? What does that mean to solve the triangle? Find the other angle? Is that it? And the two sides. So when you're asked to solve a triangle, we know that triangles have 3 angles, we know triangles have 3 sides, and we're being asked to figure out what the measurements of all 6 of those pieces are. So all 3 angles, all 3 sides. Usually we're given half of them, and from what we're given, we have to figure out the other half. Okay? The other thing to realize as we talk about these triangles is that we generally are going to label our angles with capital letters. So if you see capital letters, they're talking about angle measurements. And then our sides are going to be labeled with lowercase letters. But we also have to keep in mind that the side with the corresponding letter has to be across from the angle with the same letter. So in other words, if angle A is up here, side A has to be the side across from it. Okay? And if angle B is this angle here, then side B is going to have to be this side. And if angle C is here, then side C has to be this side. Okay? And that does make a difference when we're being given information about the triangle to understand that's how the sides and angles have to be related to each other, because it can then affect the kinds of answers we're going to come up with for what the unknown angles and sides are going to be. Okay, so angles are uppercase, sides are lowercase, and corresponding angles and sides need to be across from each other. Okay, the other thing to keep in mind with this is that because we're back to talking about triangles again, that when we talk about finding unknown angles, we are more interested in degree answers than radian answers. Radian is more of a rotational kind of thing, whereas in triangles it's more about degrees. Okay, so we're going to be talking about degrees when we talk about angle measures. Okay, so now that you know what you're supposed to do, try it. See if you can figure out what the missing pieces of this triangle should be, what measures they should have. Alright, let's see what we've got. So, one of the things that I find helpful, and I would suggest that maybe you want to do this as well, is that whenever I'm asked to solve a triangle, if I don't already have a picture, I draw a picture. We already have the picture in this case, so that's already taken care of. And then I set up sort of this, I don't know if you want to call it a grid or just kind of an organizational way of keeping track of what information was already given to me, and then which pieces do I have to find, and then as I fill in those missing pieces, knowing when I have all 6 of them figured out. So I just list the capital ABC on one side for the angles, the lowercase ABC on the other side for the sides, and then I can start filling things in. Okay? So I start with what I already know. What did they already give me for information to start with? Okay, so A is what? 52 degrees, and C is 90 degrees. Okay, because that's what that little symbol means. Anything else? For side A. Okay, so that was the information that I started with. What seems to be a pretty easy piece to figure out first?
Angle B.
Why?
Because you already have triangles.
And what do we know about angles of triangle?
There are 3 angles in this one, 20.
So we know from geometry, or at least I hope you know, I hope you remember, that the 3 angles of a triangle have to add up to 180 degrees. So if I already know 2 of them, it should be pretty easy to come up with a third one, right? So angle B is going to be to take 180 degrees and then subtract from it the 90 and the 52, which if I put those together gives me a 142. And so angle B is going to be how much? 38 degrees. Okay, so that was the easy one. Now what about those sides?
Sine, cosine, tangent, so we figure it out.
Okay, so we are working with the right triangle, which from last chapter and from geometry, we should know allows me to set up the trig ratios, right? So if I want to figure out side B, and I now have 38 here as this angle, then what is one way I could set things up to figure out side B? If I want to figure out this side, what's something I could set up for a trig ratio that's going to allow me to find B? Tangent of what? 52 is going to equal,
A over B.
and A is? So that's one possibility. What would be another possibility?
I did it like 52 degrees over 14, and then 90 degrees over x.
For B?
For C. Oh, sorry.
Nope, we're just doing B at the moment.
You could kind of do the same thing for B.
Okay.
You could do
Yeah, we'll come back to that in a second, because that's not using stuff that we talked about last chapter. So from what we know from last chapter, is there another way we could set up figuring out B?
You could figure out like C first, and then use that to figure out B.
Okay, but I want to figure out B. So I'm asking, is there another way to figure out B? Do I have to take the tangent of 52? No. I could have taken the tangent of 38 and then done B over 14. Okay, would have given me the same answer. Okay, so if we do this, what does B end up giving us? swap these two, right? End up taking 14 divided by tangent of 52. What do we get? What'd you get?
When you multiply 14 times the tangent is 0.
Say that again.
You multiply 14 times the tangent.
No. Because 14's in the numerator,
10.93.
right? So I'd have to, if I was going through the actual steps, I'd have to multiply the b to the other side. And then I'd end up having to divide by the tangent of 52. So 14 has to get divided by tangent of 52. Okay. So anybody got it? 14 divided by tangent of 52?
10.93.
10.93.
8. 7.
So most of these answers are not going to come out even. Every once in a blue moon it happens, but most of these are going to come out as some decimal. So when you're writing down these answers, generally 1 or 2 decimal points is fine. And I don't really care whether you go 1 or 2, but I would recommend you be consistent. So if you decide to go 1 with B and make it 10.9, then when we figure out C, go 1 decimal point with that also. Don't do 1 and 1 and 1, 2, and just be consistent. Okay? Alright, so C. What should I do to figure out C? So I could go sine of 52 is going to equal what? Okay, so that's one possibility. Is there another possibility?
Cosine of 38 equals wait, 14 over C.
So the cosine of the 38 is going to be the same as the sine of the 52. So I could set sine of 52 equal to 14 over C, or I could set cosine of 38 equal to 14 over C. Either one would work. Any other options?
B squared and A squared.
So Pythagorean,
Yeah.
all right, go a squared plus b squared equals c squared. That would also work. Anybody else got an idea?
Sine of 38 equals 10.9 over C.
Okay, we could go with that as well. Generally speaking, though, if you have an option between an accurate number we've been given and a rounded number that we found, which one's going to probably give us a more accurate answer for C? Probably the accurate one we've been given, okay? So when you can, if you have a choice between given numbers and rounded off numbers that we found, try to go with the given numbers, okay? So something like this, again, we're going to have to multiply by the C and then divide by sine of 52. So what is C going to end up being if I take 14 and divide it by the sine of 52?
17.36
Okay, so again, just staying consistent with the 1 decimal point. And so 17.8 is going to be my C value. If I was given units on the lengths of my sides, then I need to keep units in my answers for the sides that I find. If I'm not given any units for the ones that are given, then I don't have to worry about units on the ones I find. Okay? So again, consistency. Any questions about that? Does that make sense? Okay? So, just using what we already know from last chapter to help us do something a little bit different. This idea of solving a triangle, finding all of the angles, all three sides, finding all of those pieces means I've solved the triangle. And I was just using different tools from last chapter with trigonometry to do that. Okay? All right, well, sometimes our information is given to us actually in a picture, like this one, and sometimes we're just told. So here's the situation where I'm being told that we want to solve a triangle if angle C is 103 degrees, angle B is 28 degrees, and side B is 26. Okay? So again, in this case, since I was not given an actual picture to start with, that would be my first step. Draw yourself a quick sketch. It doesn't have to be perfect. It doesn't even have to be to scale. It's really just to help you organize which measurements go where. Okay? So I'm just going to make myself a quick sketch here. Something like that. I'm going to name this one A, this one B, and this one C. It doesn't really matter, just label them. And so what I know here is that angle C is supposed to be 103 degrees. Angle B is supposed to be 28 degrees. And side B is supposed to be 26. Where should I label the 26? Between A and C, because I have to be across from angle B. So it's this side that's going to be the 26. Okay? What's different about this triangle from the one we just did? It's not a right triangle. Made obvious by the fact that 103 is obtuse. So there's no way, even if I find this angle, that it's going to be right. Okay? So that means if I'm not dealing with a right triangle, that I cannot use all those right triangle tools that we did on the last problem to figure out the missing pieces. I cannot set up trig ratios like we do in right triangles. I cannot use Pythagorean theorem like we can in right triangles. So I need some new tools. Okay? And that's where we come to kind of what Schaefer was talking about, if you heard what he said in suggesting one way to figure out our C side on the last problem. What he was basically explaining is what's called the law of sines. And the law of sines says if we have a triangle with our three angles and our three sides, and the sides are across from the angles and all that good stuff, then there's a ratio that we can set up between the sine of the angle and the length of the opposite side. So the sine of A over the side A, or the sine of B over the side B, or the sine of C over the side C. And what's true in any triangle, not just right triangles, but any triangle, is that whatever that ratio is, it has to be equivalent for all three of those ratios. Okay? So, if I have enough information about a triangle that I can set up two of the ratios into a proportion, and I can fill in 3 of the 4 spots with stuff that I know, then I should be able to find the unknown spot by solving it out. That's our goal with the law of sines, is to try to set up 2 of these ratios. Doesn't matter which 2, but be able to set up any 2 of them equal to each other as a proportion so that I can solve the proportion to solve for an unknown piece. And what this is saying is it doesn't matter which way we set up the ratios. We can either put the sines on top and the sides on the bottom, or we can do the reverse. What matters is that I'm consistent. Whichever way I do one ratio, I gotta do the other ratio to make it work. Okay? So if we go back to our problem here, let's see. we can start filling in what we know and then start thinking about how am I going to figure out what I don't know. So I know the C value was 103. I know the B angle was 28. And I know the B side was 26. So what's the first thing you would probably try to figure out on this one? Yeah, we could still figure out the angle as our first piece because we're still being given 2 out of the 3 angles, and even though it's not a right triangle, it still has to add up to 180 when I add up all 3 angles. So for angle A, we can take 180 minus what? Oh, yeah, so I put them all together. Yeah, we're saying the same thing, just different. And what do we get? Okay, now where it gets a little more tricky is with the sides. Because if I don't have that right triangle and I can't set up the trig ratios based on that, then I need something else. So let's try to use that law of sines. Can you see an angle side pair across from each other that we already know? Yeah, B and B. And again, that's why this organization of listing all the angles and then listing all the sides can also be helpful, because then you can see, oh look, I've got these 2 measurements right across from each other. That can help me set up a law of sines kind of situation. So my first, let's say I want to do A first. Okay, my first ratio in my proportion is going to come from the sine of 28 over the opposite side, which was 26. That's the one I know. That's the one that's been given to me. That basically sets up what the ratio is supposed to be. And then I can set that equal to another ratio so that I get a proportion that I can then solve for a missing piece, an unknown piece. So if A is the side I'm trying to find, what should my other ratio be? What should I put in this ratio in order to help me find A? Sine of the 49, angle A, over side A. So that sets up a proportion for me, and the only piece of that proportion now that I don't know is the A. So I should be able to solve for that. And how do we solve proportions? Cross multiply. Yep. So that means that I'm actually taking 26 times the sine of 49, and that's going to have to be equal to A times the sine of 28. Right? Cross multiplying. So then to get A by itself, I'm going to have to end up dividing by the sine of 28 to end up with what my A value is. Alright, so if we do that, we're going to take 26 times the sine of 49, hit equal so that I'm taking that whole numerator and dividing it by the sine of 28. Anybody else got it? What'd you get, Emily?
41.79.
Okay.
41.8.
So 41.8. And since it's little a, it's a side, so I don't need any degree symbol or anything on it. It's just a measurement for length. Oops. 41.8 should be my A value. Okay, and then for C, how am I going to find my C value? Can I use Pythagorean? No, because remember, this is not a right triangle, so I cannot use Pythagorean to get my third side on this. So what am I going to have to do?
Sine of 28 degrees over 26 over sine of 103 degrees over C, side C.
Okay. So go back to the ratio that we know from what was given, the sine of 28 over 26. But now for the second ratio, set up what I need to find side C. So I need the sine of 103 over C to solve that proportion. Okay, so solve it, what do we get? 54 point, because I went to 10th place there, so what would be my 10th place? 53.9?
Yeah.
What was after the 9?
So,
Was it really? Are you sure? I was thinking from the other class that it was a little bit different. 103 sine times 26 equals divided by 28 sine. I got 53.96199.
Wait,
Somebody else do it and tell us which one's right.
oh, I rounded this sine 28. That's why.
Yeah, keep it on your calculator. Don't round until the very end. So we want to keep these as accurate as possible. So if I rounded the first length to the 10th place and therefore want to keep consistent, so I want to round to the 10th place again, what is 53.96199 going to be to the 10th place? Alright, so there's a few decimal places, but what's that going to be if I round it to the 10th place? Yes. Good. Because this 6 tells me that this place should go up 1. But it's already a 9. So if it goes up 1, it's really going up to a 10, which means putting 0 in that spot and carrying the 1 over to here. But then the temptation is to want to say, oh, so it's just 54. But if you just write 54, anyone else who looks at that thinks that you were intentionally rounding to the 1's place. And that wasn't the case. You were intentionally rounding to the 10th place. So we keep the 0 in there in the 10th place to show that is the place that we were rounding to. So 54.0 should be your answer for the length of side C. Okay, a little rounding, remembering, reminder.
how did you get 52.96 again? Because I didn't round anything, I still got 41.7.
Because you were taking the sign of 49. We're taking the sign of 103 for C. So you were still getting this answer.
Oh.
You were still working this one out. We're on 103 now, so you gotta work this one out.
Wait, Mrs. Gordon?
Yep.
So, like, I'm still trying to figure out, like, you said you wrote sine 28 over 26, like, is it the pattern just showed us, like, why, I'm so kind of confused, over this side, okay. Thank you. Okay.
right? This is what the law of sines allows us to do. It says that if I set up this ratio of the sine of an angle over the opposite side,
Yeah.
that ratio has to be the same for all three possibilities. So I'm using that fact to set up proportions so I can solve them.
Oh, yeah.
So the one I know is the 28 and the 26. They're across from each other. So that's kind of my, what do I want to call it? My basis for what the ratio should be, right? And then my other ratio that I set up to complete the proportion is the ratio that includes whichever piece I'm trying to find. So when I'm trying to find A, then it's got to be the sine of 49 over A.
Okay, thank you.
When I'm trying to find C, then it's got to be the sine of 103 over the C, because that's the angle that's across from it.
Makes sense.
Okay.
Thank you.
Any other questions on that one? All right. Try one on your own. My recommendation with these, even when it's on your homework, is draw yourself a quick sketch first and label what you know. Then set up the little organizational ABC. Fill in what you know, and then start going to town on figuring out the unknowns. Alright, see how we're doing. Alfred, what's the first thing you found?
I found 8.
And how'd you do that?
Just did 82 plus 55, and then I subtracted 1 by the answer.
So what was 82 plus 55?
It was 137.
And what's the answer you got when you subtracted?
43.
Everybody agree with that? 43 for angle B. Okay. Alright. Nicole, what'd you find next?
I got B. Oh,
Side B?
Side B, sorry.
Okay. So how'd you find side B?
Sine 55, so 55 degrees over 8 equals sine 43 degrees over B. And I did the math.
So what'd you end up with for B?
Wait a second. I think mine is wait, it's fucking not 9.6. 9.7.
9.7?
6.7.
6.7.
I got 6.7.
6.7?
Yeah, 6.7.
I got 6.7.
6.7? Okay, so remember kind of the shortcut? I mean, it's what we did step by step a minute ago, but it's take 8 times sine 43, the two across from each other that we know, and then divide by this other one that we know to get that one, right? Alright, so that makes this one 6.7. And then, Morgan, what'd you do for C?
And I did the sine of 55 over 8 equals the sine of 82 over 6. And I got 9.7.
What was it, 9.78?
7.8, so
So if we want to stay consistent, what should we put?
9.8.
9.8. Okay. So any questions on that? Alright, then our last problem for today, we want to be able to take this and use it in a more realistic kind of situation. So this is actually the problem that's at the bottom of the back side of your notes page, if you haven't noticed it yet. It's written out there so you don't have to copy it down. Okay? So it says we have a 123-foot support wire for a transmitting tower, makes an angle of 61 degrees with the ground. This wire is to be replaced by a new wire whose angle with the ground is going to be 46 degrees. So the question is, how long will the new wire be? So the first thing I want you to do is to draw a picture of what's going on in this problem. Don't try solving it or anything yet, just draw the picture. Transmitting tower are those big, like if you're out away from cities, usually out in the country, and you just every once in a while in a field, you just see those big, tall, skinny metal towers that have the lights blinking on them. They got all kinds of wires coming out of them. Those are transmitting towers. They're usually for radio or for cell phone. Okay? Alright, so there's my ground. What's my tower going to look like? How should I draw my tower? Like this?
That's your water.
Do you think that's what my tower looks like?
No.
Probably not, or it'd fall over. Okay? So probably what's going to be the case between my tower and the ground? What do you think is going to be the case between the tower and the ground? If we're assuming that my tower's straight and not leaning over one way or the other, then what's the relationship between that and the ground?
It's a right angle.
Yeah, it's probably going to be a right angle. Because there's nothing about this problem that tells us that the tower is leaning in any way. Now, it could be, you're going to see some problems where it's talking about a tree that because of the wind over time, it's actually not standing at a perfect 90 degree, it's slanted over a little bit. Or you might have a tower which is standing up straight, but it's actually on a hill. So it's not going to create that 90 degree angle. So you are going to have those kinds of situations, and you have to read carefully to know what's going on. But in this situation, there's nothing about what we're told that makes us assume that our tower isn't straight up and down. So we can pretty much assume that that's going to be a right angle that's formed with the ground. Okay? And then the wire that supports it is coming down from the top like that, and we're told this right there, where the wire and the ground come together, creates a 61 degree angle. We are also told that the wire itself is 123 feet. Okay? But that wire is going to get replaced with a new wire. And our new wire is going to create a 46 degree angle with the ground. So would you imagine that this new wire is going to be attached closer to the tower or farther away from the tower?
Closer.
No.
Which one's going to give me a 46 degree angle compared to the 61 I have right now?
From the ground.
It's going to make the angle with the ground, but I want to know from the tower, will I attach to the ground closer to the tower or farther away from the tower?
Farther away.
Farther away. So in order to get a smaller angle here, I'm going to have to be farther away from the tower. Okay, so your picture should look something like this. Based on the information that we have, this is what we envision is going on. Okay, so what are we trying to find? How long is the new wire? So we're trying to figure out how long blue is right there. Any ideas?
Figure out the top angle first. Use some information we're getting.
Figure out which part first?
The top angle.
We could. Would that be helpful to us? Not necessarily. So here's one of the things to understand when you start working with the application problems with some of these rules, theorems, whatever you want to call them, that we give you, like the law of sines. When you get to an application problem, it's not usually about solving the entire triangle anymore. It's about solving for the missing piece, solving for the piece they're asking about. So we don't necessarily have to find the third angle unless it's helpful to us. If finding that third angle helps us figure something else out, then great. But if it's not really going to help us find anything else out, we don't have to find that third angle, because we're not really being asked to solve the entire triangle. we're being asked to find this particular missing piece. Okay?
119 the one next to 46.
119 for what next to 46? The wire?
The ground.
The
The one that's supplemental
Next to-
is 61.
the one what? Use your
Angle,
words.
Angle.
Angle. You're talking about an angle?
Yeah.
Oh, I can tell if it's angle or length or okay. So an angle. Oh, I'm gonna need to skinny this up a little bit. So he's saying this angle right here is 119. How'd you find that, Alton?
180 minus 60.
Yeah. So the fact that these two angles together give us the straight line of the ground, and the straight line angle is 180, means if I take 180 minus 61, I should get what's left over here. How is that helpful?
Unless you have another piece to set up another ratio, I guess.
Yeah, exactly. So what's one ratio that I could set up from what's labeled right now?
Sine of 46 degrees over 123.
Yeah. So we're basically looking at just this part as the triangle of interest. And in that triangle, the 46 degrees is opposite of this old wire, which we were told was 123 feet long. So that allows us to set up one of our ratios. And then what's 119 across from?
X.
X, which is what we're trying to find. So that allows us to set up our other ratio. And then solve for the missing piece. So if we take the sine of 119, multiply it by 123, and then divide by the sine of 46, how long should our new wire be?
Oh,
149.62?
Yeah.
And does that make sense? Does it make sense that the new wire should be longer than the old one? Yeah, because if I'm putting it out here farther away from the tower, it would make sense that that wire is going to have to be a bit longer. So 149.62 feet for the new wire seems like a reasonable answer. Anybody try this a different way or see another way to do this?
Can't you just get rid of the middle and do
You can't completely get rid of it because we need it to find a different piece. But what were you saying? If we got rid of it, then what did you want to do?
so but it wouldn't
Did you say stoichiometry?
yeah, isn't that
You know we're in algebra class, not
Oh,
chem
that's-
class,
that's
right?
in
I don't think we're balancing chem equations here. Unless we want to talk about the rust on the tower or something like that going on, like, you know. But what else might, I mean, if you look at this and you see how the tower really is perpendicular to the ground, where else might your brain go in terms of trying to figure this out? Right triangles, right? right? I mean, if we see that the tower is going to be perpendicular to the ground, we know we have a right angle. So another way you could do this, and it actually takes 2 steps, but it can be done this way. You just consider this triangle first and figure out how tall the tower is. Right? Because I have enough information for that. I have this 123 as my hypotenuse, and I've got the 61 here as my angle, so I can set up a sine of 61 to figure out what my tower would be. And then once I know what the tower is, then I consider this bigger right triangle with the 46 angle, and I set up sine again, but this time I know this side, and it's this one I'm going to figure out. And I end up with the same exact answer. So again, I'm just pointing that out to remind you that when we get into application problems, there may be more than one way to get your answer. Okay? So think through your options, think about what makes more sense, think about the tools that you have at your disposal that you can use. But when you see something that actually does appear to have a right angle, or that we're being told something that either is flat out, hey, right angle, or it's pretty safe to assume that we're working with a right angle, you know, don't throw the right triangle trig out the door just because it was last chapter. Right? There's still a lot of that we can use to help us. But the nice thing about this case is if we can narrow it down to just that purple triangle that's created by the 2 different wires, it really just takes 1 step to find our missing piece after we figure out the 119 angle. Okay? Okay, so that's really going to get you through what you need for homework, for your practice. Because we've got quite a bit of time, I'm going to ask you to do something quick before you get your practice going. And then, if you've got time left, by all means, go ahead and start your practice. But if you turn a few pages in your booklet to the page that looks like this, it says, Law of Signs, Ambiguous Case, Foldable Directions. Okay, looks like this. Next class on Monday, we're going to talk a little bit about law of signs, because there's one situation with triangles where we get kind of weird answers from law of signs, and we need to know how to deal with those. So we're going to talk about those next class. To help us with that, we're going to be making a foldable that helps us with what the possibilities are for the kinds of answers we can get in this weird case. So it would help if we had the foldable ready to go today, so that on Monday, as we go through the lesson, all we have to do is just fill it out. So this page is giving you the directions to the foldable. I'm asking you to do steps 1 through 6 right now. Since we have a little bit of time, we've got materials here in class that you can use. Do steps 1 through 6 here in class, and that way we'll be ready to go with filling it in on Monday. Okay? So you're going to need 2 pieces of paper. It says they should be different colors. So we've got green and pink up here that should work pretty well. So take 1 of each of those. And then we've got some scissors and ruler and stapler, all of that kind of stuff that you're going to need at some point in the steps. So those are up here as well. So use the materials, work through those first 6 steps. When you are finished, just stick it in your book so you make sure you bring it back again on Monday. And then if you have any time left, by all means, start working on your 3.1 practice. Okay? Okay, go. I'm going to get 1 pink, 1 green. Start working on your foldable.